Yo, 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 this is Maturo, and today we're going to learn about the graph of parent functions. Okay, we have learned already from Algebra 1, Algebra 2, linear, which is y equals mx plus b. That's the common equation for linear. That's a guide. The b the y-intercept, m is the slope. Quadratic, which is like a like a U shape. We call it parabola. A cubic, it's like an S, but it's not. Absolute value, which is looks like a letter V shape. We have also reciprocal function or the rational function wherein they're symmetrical with the origin. It's an odd function. And the square root, I call it square root. Okay, so it's like a letter R. And there are more, the constant function, logarithmic and exponential, natural log, those things. Okay, but we're gonna focus with this sixth one here for now. So how do we graph them? For the y equals mx plus b, if you're given y is equal to 3 halves x minus 3, so you start at negative 3 here, go up 3 over 2, go up 3 over 2, and then you just simply connect them. It's a line, it's a linear function there, right? For the y equals x squared minus 4, you start at negative 4 here. That's your y-intercept there because you don't have a b. That's your a and that's your c. And then I call it the 135 rule. That means you go up one from the vertex, go over, go up three over, go up five, 1, 2, 3, 4, 5 over, and then do the reflection on the other wing, and you will see that the parabola, if you connect them all, makes the U shape. Okay. All right. That's for the quadratic. What else? For the absolute value, y is equal to absolute value of x. It's from the origin, one up, one over, one up, one over, one up, one over, reflection on the other point. That's the V shape looks like. Okay, and that's the rule. It's like one up, one over. Follow the slope. We also have the square root, one square root of x, which you follow the 135 rule. So from the origin, up, over, up one over three, up one over five, and just simply connect them, and that's your square root. It's a positive square of x. Okay, and there are more. There's the cubic. Oh, the cubic. I have to go over the cubic. Cubic is, I call it the three kings. Why? You go with the origin, you go with the one there and this, and the graph will be something like that already. Okay, that's the x cube, the cubic function. Okay, all right, and that's the idea. Okay, I still have. Oh, I haven't done the reciprocal. For the reciprocal for the rational function, it's just like it gets closer to the asymptote of the y-axis or the x equals 0, and go here and then get the symmetrical on the other one here. Okay, we will discuss that one in the previous chapters. Okay. All right, so we are going to talk about today the vertical and the horizontal shift of those parent function. Okay, so vertical shift c units goes upward if the function f of x will have a plus c outside that function, and obviously it will be downward if it's a minus c. So a while ago I showed an example of parabola. If you notice there, the value of c there was negative 4, so it goes down by 4 units. So the parabola goes down. So in horizontal shift, it goes right or left. Okay. So if it's a minus C, you go right. If it's a plus C, you go to the left. Why is it so? Because x minus C, if you set it equal to 0, you add C on both sides. That becomes x equals a C, a positive C. That's why it goes to the right side. Okay. And vice versa. If it's a plus, it becomes minus, so you go to the left. Okay. And I'll show you an example here. So if you're given f of x equal to, let's say, x, that's the linear function. You go to the origin, go up one over, one up, one over, or down one left, down one left. So the graph of the first function is that. So this is the f of x equal to x. But if I add f of x, let's say plus 4, that means the graph started at 4 here, up one over, or down one left, down one left. If you compare the pink and the red shifted up 4 units away from the origin, one, two, three, four. Okay. And guess what? If you have f of x equal to x minus 3, from the parent function, the red one here, it will go down 3. 1, 2, 3. All those points will go down 3 units, and the entire line looks like it shifted down or up by 4 or by 3 respectively. Okay. Now, if we have a parabola, same thing, f of x equal to x squared, that's the parent function. So start from the origin. There's the term 135, up 1 over, up 3 over. That's good enough. Those points, copy the reflection, and then make your parabola here like a U shape. But if you end up with f(x) equal to x squared minus 6, that means all those 5 points will shift down 6. Or you go to the origin at negative 6, then up 1 over, up 3 over, reflection on the other side, and just simply connect them. So the black parabola looks like it shifted down. Or if you have f of x equal to horizontal shifting, let's say x plus 5 squared. If you notice, this is plus 5 inside the parenthesis. If it's a plus, we go to the left by the C unit. So since this one here is positive 5, so I'm going to go to the negative 5 there, and I go 1 up, 1 over, up 3 over, reflection on the other side. So the graph, if you compare the parent function, the black graph, to the pink graph, it shifted 5 units to the left. Okay. Very similar with the absolute value, square root, so let's do absolute value here. So say you're given f of x equal to absolute value of x, it's 1 up, 1 over, 1 up, 1 over. Okay. So if you do f of x equal to absolute value of x minus 3, that means you're going to go right 3 here, 1 up, 1 over, 1 up, 1 over, and you connect them. That is your graph now. Okay. Very simple. Okay. So let's try this time how to write a function from the graph. Okay. So here you see my absolute value. So I know that my function here will have an absolute value. Okay. It has moved from the origin, moved by 1, 2, 3, 4 units to the right. If it goes to the right, so this will be x minus 4 because it's minus. Again, going back, if it goes to the right, it becomes x minus c. Okay, it becomes minus. Now, and also it goes down by 2 units, so there will be a minus 2. If you notice, the number outside here is as is. It's the same. If it's a minus, you go down. If it's positive, it goes up. Okay, and that's the graph of that one. Okay. For the parabola here, it's a function f of x. It's a parabola, so it's going to be x squared. But this one goes up by 1, 2, 3, 4, 5, 6, 7. 7 goes up by 7 plus 7. The difference is that this is upside down. It opens downward. So this x squared has to be negative. That is the reflecting portion of the function. So if it's negative, the leading coefficient becomes negative, it flips over. So if this one here is negative absolute value of x minus 4 minus 2, this will be going down like that. Okay. And last one here is a square root because I see the r there, just like an r, and square root. And this is went to the left by 3. So this will be x plus 3. And then it goes up by 1. So there will be a plus 1 outside the square root. And that's the answer for this graph here. Okay. And that's how you write a function from the graph. So again, the reflection and shifting. So if you're given f(x) equal to square root of x plus 5 and then minus 2. That means you go, let's put a negative here. Okay, so let me change it. Sorry. So let's do f of x is equal to square of x. That goes up from the origin up 1 over 1, up 1 over 3. The formula here is also 135, but it goes sideways. That's the square of x. If we have f of x equal to negative square of x, that goes down from the origin, down 1 over 3. It goes this way here. If we have f of x equal to square root of negative x, that goes up 1 over left from the origin, up 1 over 3. The graph goes going the negative value because you can only accept negative there because there's a negative outside. Negative times negative will be kept into positive. And the last one there, pink. If you have f of x equal to negative of square root of negative x, that goes down 1 left, down 1 over 3. It goes the other way around. Okay, that is the basic reflection for the square root function. Okay, and so if I ask you to graph, let's say f of x is equal to, let's say, negative square root of x minus 4, that means you go right 4, and then let's say I have a shifting of minus 4 here. There are two minus 4. One is inside, one is outside. Go right 4, down 4. And then since that's negative, you go down 1 left, down 1 right, down 1 right 3. So it's still 1, 3, 5. There you go. Okay. All right. That's all for me today. I hope you learn about the graph of the parent function. As always, kaboom.